was solve the right triangle. I didn't even put the answer up for the height of the wall, but it's really the setup of, am I going to use the Pythagorean theorem, or am I going to set up a SOHCAHTOA to find a missing side length? But in order to have done that warm-up, you would have to, like we set up, I think it was like tangent 25 equals x over 3, and then we would multiply both sides by 3, so you'd have to know how to enter things into the calculator. So type these into your calculator, sine, cosine, and tangent. If you have a scientific calculator, you should be able to locate those buttons and help each other out if you need to. I'm going to just put my answers up so that you can see if your calculator is giving you the same thing, and you'll call me over if it's not. And when you're doing trig ratios, I would say you probably want to round to like the nearest thousandth or 10,000. So that would be 3 or 4 decimal places, or 3 or 4 numbers after the decimal. Okay, so flag me down if those are not what your calculator gives you. And you guys, with the graphing calculator, shall hit the mode next to your center button. And the default mode for your calculator is radian. It's the third one down. But you're going to go change it to degrees. On Thursday, we're going to talk about radians. So then everybody will be switching back and forth out of those. Anybody else not getting those answers? The graphing calculators have a default mode of radians, which will give you different answers, but the smaller calculators have default modes of degrees. Okay, now, that's pretty good. Everybody knows how to do that from geometry, not too much trouble. Okay. One thing we should talk about and make sure everybody is okay with is, how do you do a reciprocal in the calculator? So kind of look at your calculator. Now some people might look above the sine, cosine, and tangent, and they see those things that look like sine with the -1, cosine with the -1, and tangent with the -1. Okay. These are not reciprocal, or these are not reciprocals. We'll use them later. They are inverses. So that reads, when you see that sine with the -1, you say inverse sine, inverse cosine, inverse tangent. And the inverse is not the same as the reciprocal. So there is really no button for cosecant, secant, and cotangent. But you can use the fact that they are reciprocals, right? So what do we say reciprocals mean? We're just flipping things. So cosecant was the reciprocal to which trig function? Sine, for which there is a button on the calculator. So if you want to do a cosecant of theta, you do 1 divided by the sine of theta. So you're actually flipping sine theta in the calculator. It's like sine theta divided by 1, and then you flip it, 1 divided by sine theta. Secant would be 1 divided by cosine theta. And cotangent, you'll type in 1 divided by tangent theta. Okay. These are called, later on, reciprocal identities. That would be like an algebra 3 or a pre-calc topic you'll study. You'll know all these different trig identities. So kind of make a mental note of that. That's something, even when in pre-calc I'm talking about trig, some people forget and they want to do the second sine, second cosine, but those are inverses, not reciprocals. So just to verify that your calculator is in working order, I will have you do these 3 in the calculator, and then I will write up my decimals and we'll see if we're all getting the same answers. If you want to verify with your groups what you think you should be typing in, go ahead and do that. you do not get those 3 decimals, let me know. What did I type for cosecant 50 in my calculator? Cosecant is the reciprocal to which trig function? Cosecant is the reciprocal to sine. So I typed 1 divided by sine 50. 1 divided by sine 50. I can't do cosecant of 50, but I can do its reciprocal sine of 50, and then to flip it, I would just divide that 1 divided by that ratio. This one would be 1 divided by cosine 32, and 1 divided by tangent 84. Do you know what your... Is it because you were matching the S's and the C's? Oh yeah, we talked about that yesterday. They mismatch. It's weird. Okay, any questions or concerns in the calculators? I will say this. If I can avoid setting up a reciprocal identity, just because this, to me, is just like a little bit extra tedious, I usually, like if I'm doing that ladder problem, I set up a sine, a cosine, or a tangent, right? Because those are the buttons that are on the calculator, so I usually use the 3 basic ones. But you should know how to use the reciprocals in case you need to. Okay, so now on to the notes about solving the triangles. Okay, be aware when you read a direction and it says something like solve a triangle. It would mean find everything that's unknown. All the missing sides, all the missing angles. So if you think about a triangle, you have 3 sides, you have 3 angles. At the end, you should know 6 pieces of information. Obviously, in order to be able to solve, some pieces of information will be given to you. Usually it's about 3 pieces of information. So here's an example without any context, where I just give you like a triangle ABC, and let's say I said, solve the triangle. Capital letters are for angles, and the lowercase letters are for sides. Some of those things, I usually just write all 6 down. Some of those things I already know. Like I already know B is 62 degrees. I already know, notice you should remember this from, I already know C is 90 degrees, right? Because I have a 90 degree angle. You should remember this from geometry. Like across from angle B or opposite of angle B is side B. Opposite of angle A is side A, so A is 6. And then opposite of angle C, usually your right angle, is your hypotenuse, side C. So like there's 3 things I know. I'm really responsible for finding the measure of angle A, the measure of side B, and the measure of side C. Raise your hand if you can tell me how to find one missing piece of information. Tell me.
Well, you can find angle A just by subtracting 62 to 90 from 180.
Yeah, so like all 3 angles in the triangle add up to 180. So Tommy says take 180 minus 90 minus 62. Or you could have just done 90 minus 62 because there's that rule like your 2 acute angles have to add up to 90. So angle A is 28 degrees. Think about how you might be able to solve for side B or side C. See if you can write some kind of equation. that would allow you to solve for side B or side C. Raise your hand if you've got an equation that will solve. Dylan?
To get side B, you can do tan 62 is equal to B over 6.
Awesome. So we're going to solve this one first, but did anybody have any other equations different than that? Maddie?
I had cosine 62 equals 6 over c.
Okay, any others different than those two? Tangent 62, cosine 62. We all wrote one of those versions. Okay, yeah, I mean, you could do the sine of 28 is 6 over c. You could do the tangent of 28 is 6 over b, right? Like, there's multiple trig ratios that you could write at this point. I'm going to go ahead and solve Dylan's. So we would have to multiply both sides by 6. My b's always look like 6. And then this I can just type into my calculator, right? Make sure you're in degree mode, so you do 6 times tangent 62. 6 times tangent 62, I get 11.3. Anybody agree with me? Yeah. So B is 11.3. Now, how might you find C? Delaney? Yeah, I'm going to guess a lot of people, after they find one of the missing sides, then they'll do like what Alex was attempting on that first warm-up, Pythagorean theorem. If you know 2 sides, then you can find the missing side, right? Okay, so we could set something up like c squared equals 11.3 squared plus 6 squared. Let's see. 163.69 and square root both sides. I get 12.8. We should also be able to, if you wanted to like get more practice with trig ratios, you could solve Maddie's for C, right? So let's just, like, Maddie's is a good one for us to also practice. Because in Maddie's ratio, notice that 6 over C, C is in the denominator instead of the numerator. So, like, if you were solving it like we solved Dylan's, we multiplied by the 6 that was in the denominator. So I would say, like, multiply by C on both sides. But then I'll have C times the cosine of 62 equals 6. Now I divide both sides by cosine 62. You may also have been taught to like cross multiply right there. Okay. But either way, you're going to end up doing 6 divided by cosine 62. And I get 12.8. So whether I used the Pythagorean theorem or a trig ratio, I'm getting the same answer for my side C, right? Either one is acceptable. And that would be true if you set up like different trig ratios. I noticed we both use 62, but you could use this 28 like I had. Like if you do tangent 28 is 6 over C, we should still get 12.8. Any questions on that? Okay, the last thing that we need to discuss just really quickly, and you can decide like if you want to write something down about angles of elevation or depression. I'm really just showing this slide because I want you to like be okay with this, but I don't know that you necessarily have to write all of this down. Angles of elevation are looking up, I always think, and angles of elevation are when you're looking down. And what I'm talking about is like what if I was just looking straight ahead, okay, and then if I'm looking to the top of the building, that's an angle of elevation. But if I'm looking down from my lifeguard stand at the pool, then that's an angle of depression. So it's like think about where your line of sight is. Normally you would be looking straight ahead, and then whatever object is being described, are you looking up or are you looking down? Okay, and that would help you draw your picture. So we'll talk about this example. I wanted to do this because maybe some of you have used this tool in like physics or another science class. It's called a clinometer, but I just want to, that's a good vocab word for us to talk about. So you don't necessarily have to write out the whole word problem. If you want to write like a short like scenario or something in your notes, you can. But let's say in physics, you and your partner are tasked with building a rocket. You are standing 20 feet from where your partner will launch the rocket. Using a clinometer, which this is a rough clinometer that we could build. So what's happening here is you could build it like, here's a straw. It's straight. This is a protractor. Okay, so it's got 0 to 180 on it. And then there's a string that you tie in the middle to the straw, and you put like some kind of weight at the bottom. And what happens is, if you're holding that straw level with the ground, parallel to the ground, then the string should drop at the 0-degree angle. Like you have no angle of elevation, no angle of depression. Okay? But then, like when your partner way over there, 20 feet away, when they launch their rocket, then maybe you're supposed to look through the straw or just follow this side of the straw. This is a really rough one. There's actually real clinometers that people have probably used before. But you follow it up, and then you would like stop it when it lines up with the max height of the rocket, and then someone can read where your string is, and it would tell what angle you had looked at. So it's a rough way for you to estimate the angle of elevation or even depression. Has anybody used an actual clinometer, like a real tool, before? I have one at home, and I'll try to bring it in. I got it at like a math conference. I'm not like super nerdy as to make a clinometer at home, but I got one at a math conference once. The ones I think Mr. Burke uses, if you ever take Mr. Burke's class, they build rockets. It looks sort of like a gun or something, so you like follow it, and then you like click the trigger, and it'll stop it at the angle. And so then you can like just look at it. That way you don't have that string. Like I have to hold it and wait for somebody to read my string, you know. So that's really handy. Okay, using that clinometer, you measure the elevation to the rocket's max height to be 35. Your line of sight is 5 feet above the ground because your eyeballs are 5 feet above the ground. Okay, different for everybody at different heights. What's the max height of the rocket? So I'm going to let you and your group, if you want to draw a picture like we did for the ladder, set something up, try to solve, and I'll put up my answer here in just a little bit. Okay, but I would say everybody can probably do this from geometry. You solved problems like this before. And let me know if you guys need some help. Trying to draw the picture or the scenario based on that, what that clinometer is doing. I'm spying some people's great artistic work. They put themselves into the picture. This would be their normal light of sight, right? And then I see something like this. Like I'm estimating my angle of elevation to the rocket's max height to be 35 degrees. Sort of like a firework. That's probably my favorite drawing that I saw. I saw other drawings that are just like a rough triangle, right? Without a person, without a rocket. That's totally fine. Okay. But what I really like about this drawing in particular is they're taking into account the fact that the triangle sits 5 feet above the ground, right? So we know there's an extra 5 feet. And then you would like to solve that right triangle for the height of the rocket. Which trig ratio are you guys going to use? SOHCAHTOA. Tangent. Oh, I didn't label, but we know we're 20 feet from our friend. Okay, launching the rocket. So there's 20 feet right there. So we have the opposite and adjacent. So we'll set up the tangent of 35 equals h over 20. This one we can just multiply both sides by that denominator of 20. So I get something like 20 times tangent 35, 14. So that's this height here, but the actual height of my rocket would have been 19. Plus the 5 extra because my eye level is above ground. Okay. So the actual max height of my rocket is 19 feet. Okay, so not too terrible, right? Draw a picture, I think, is super helpful. Remember what Delaney said in that warm-up. Draw the picture. And then label all the parts. You should have enough to either do Pythagorean theorem and find a missing side length or to do some kind of SOHCAHTOA. All right, your homework assignment is here.